Hey everyone, I'm really excited to be here. I'm too excited because I'm going to talk about agents with respect to coding. And if you are able to count how many times I said agents during my talk, you'll get this best squishy ball on earth. Okay, just try to count how many times I say agent. Okay, cool. So I'm going to talk about the future of try to predict and discuss the future of software development. But just before we do that, there were a few people here on the podium that talked about like just an example Copilot helping increasing code quality. Some of them said that it's actually going to decrease code quality, and there is even a report that says that there is some lower quality code generated by AI. So how can I talk about the future of AI if what we're having right now doesn't work? So I'm going to talk about, elaborate about that. And a spoiler is that at Codium AI, we released Alpha Codium just 10 days ago. And that's the state-of-the-art code generation tool right now that beats Alpha Code by DeepMind and GPT-4, OpenAI, according to their technical report, but like double the accuracy. So I'm going to that's a big portion of my talk. And that will help to understand how we are going to improve code quality eventually. I see a lot of eyebrows like, better than DeepMind, beats OpenAI, like 10 minutes and you'll see that, okay? So this is the highest level architecture for any system in the world, including Gen AI, right? There is an input, goes through some system, and then there's the output. But the reason I call it like a Gen AI architecture is because you can see that the input is like kind of vague. It's not a point. It's like, please give me a porcupine riding on a horse in space. It's not well defined. And then it goes through a Gen AI system and brings you some output. It's not a well-defined one. It's like in a space of options, right? So this is the Gen AI. And when you're dealing with images, it's actually working quite well. But when you're dealing with code, maybe it's not good enough that you're defining something in like a very high level way, and you're getting something that is not exactly what you meant. You do want to get the code working exactly like you meant it. And how does the Gen AI system like for code works right now? Most of them, like code generation, code completion, basically you get some request from the developer and you collect some naive context around it, and then you prompt the model and get the output, okay? And it's not like you don't need to blame the LLM that you get such a bad result, because basically what we did here is that we implemented a system that looks like System 1. You know the Daniel Kahneman like framework of System 1 and System 2? Do you know what I'm talking about? Just, okay, cool. So System 1 is like almost like intuition, the first thing that comes into your mind. And the second one is like a process. So if we're using LLM, like in the System 1 way, let's not blame it if it's not working and giving you some output, bad working code, okay? So we need to move to a Gen AI system that actually are more agent-like. Okay, people so-called call it agents. We can call it teammate. It's not like equivalent, but many ways to say it. And what you see here is that if you, instead of just prompting like a model, rather doing some more like thoughtful process, even one that is actually questioning the developer about what he or she wanted to actually get. Then from a wide space in the input, you can get a specific point of what you're trying to get, and also the output could get really specific. And that's how you improve the code quality. There was a great, I think one of the presenters talked about agents a lot, like just an hour ago. But I don't want to assume that all of you know what's an agent, so I'm going to talk about it really briefly. So basically, an agent has, like what you see on the right side, it has some interface. It could be an interface to the user, to the developer, via chat or other ways. It could be, by the way, another plug to another agent. And then there is some core algorithm that goes and calls some tools, does some syncing, use the memory, and it could do some process. By the way, it doesn't mean that every agent is equivalent to System 2. It could be like a bit, glorified System 1. But with this architecture, you can try to implement a system to this system, okay? A system to algorithm. Cool. So a bit about agents, because we're going to talk about it later. Like I'm opening a brackets specific window for about agents. An agent, okay, could be like a single agent and that you interact with as a developer. It could be like an agent that on the background it like uses other agents to do many tasks. Other tasks, it could be a swarm. So it's like you're calling different agents and it's not the same one. And by the way, if we zoom in on the super agent plus agent like metaphor, then actually there are two options. It could be like a super agent with other agent that it's using on the background, which are exact, or it could be like a specialized agent. I don't know which option is going to win eventually for a developer and other use cases, but maybe we can get some hints from the past. Let's go all the way back to 2016. Okay, let's take a step back and talk about 2016. In 2016, we had the gun architecture. Again, just to make sure, who knows what is a gun? Cool, a lot of people. So basically the generative adversarial architecture where you in most cases had two models. One is in charge of generating content, and another is in charge of checking the content, verifying or trying to compete against it, etc. And they were like collaborating with each other and getting each other better. And there were two different models, or like like you can see here, it's like a system that has some reflection. And so maybe that's like actually a good architecture. But as we progressed and we got like the amazing transformer architecture with the attention blocks, etc., we kind of dropped the adversarial, right? Because the generative models, whether it's decoder only, decoder, whatever, they're working really well for generating text, images, and audio. But if you remember my first slide, like all of these three media, they work quite well with this concept that I ask for something general, I get something general, and it's good enough. Okay, but when we're talking about code that we wanted actually to work, okay, and we want it to be accurate, like I mentioned, then we do need the system 2 architecture and bring back like a syncing process similar to what we had with GAN. Okay, so we claim at Codium AI that in order to create code that actually works and not just a suggestion for you, you need an integrity component. Okay? And when we're talking about integrity, by the way, notice that I changed the word from adversarial or etc. to integrity. That's what we think fits for the coding cases. We're talking about testing, about being able to reflect, about spec creation or matching that works together along with the code. And these concepts is what we brought into Alpha Codium, which is very new, like around 2 weeks old. With Alpha Codium that I'm going to talk to you about, we managed to create a system that beats the majority of professional competitors on coding competition. There are 2 companies until today that done that, like try to compete. There was DeepMind by Google, they with their Alpha Code, and OpenAI with their GPT-4 report. They tried. GPT-4 did something okay-ish. DeepMind are so good on competition, did well. And we did even better. But there's more to that. Why our solution at Codium AI of Alpha Codium, by the way, it's open sourced. You can try to run it. It's reproducible. It's out there, okay? Then why it does so much, it's so much more useful than the Alpha code, which was our original inspiration. The first reason we did so well, because Alpha Codium is focused on the code integrity. And in Alpha Codium, we presented an idea that we call flow engineering. Even Karpati, from OpenAI, he reviewed our paper and he tweeted about it. That we're shifting from prompt engineering to flow engineering, okay? What you see here is the Alpha Codium like agent. Basically what happens is the Alpha Codium takes an input as a spec, natural language description of a problem that is part like a competition, a problem from the competition, and then reflects on it, starts to generate some intermediate representation. some of them are natural language description, but more technical than the original one. And some of them are like actual tests, and then start iterating over it. The idea here is to have one part of this system that generates code and reflects on it, and another that generates tests and reflects on it. And this is like a visualization of what's going on here. Let's say that we have a problem, and the Oracle solution would be the blue cloud. If you take like the original problem and prompt a GPT-4, a really good prompt, you'll get something like a red solution. But the thing is that it doesn't work. Like we know, the GPT-4 report that shows that they did it really badly on this benchmark that we used. It's the same benchmark. But then there are also some public tests that are available. The competition that we're talking about, benchmarking against, come with a few tests. You can use that and reflect and start a flow. And already then you get better results. But then you can do a few more steps and use Gen AI to generate even more tests. You need to do it smartly. You need to find the edge cases. You need to have a good system that catches edge cases, behavior analysis, etc. And like that's our special in Codium AI. That's what we're able to do that, and eventually like use that to generate the final solution. Okay, what you can see here is a figure on the x-axis is like how many LLM calls are made to solve one problem. Let's say I have a definition. I want to add a feature to my code. How many LLM calls were made to make the final solution? And the y-axis, you see the accuracy. I'm not going to dive into it, but basically what you see here is accuracy above median developer, professional developer. What you can see with Alpha Codium, that it's not only like doing really well, but it also uses only 100 calls to generate a final solution, as opposed to Alpha Code 1, for example, that calls 1 million times. So it's not practical. There's a reason they didn't release it. Okay, they didn't release even Alpha Code 2, but that's because they specialized, like they fine-tune the model with the data, the competition data. I don't want to get into that. But think about it, 100 LM calls actually makes sense. Because if I go to you, sorry, you look like a developer, am I right? Yeah, yeah. And I ask you, here's a problem, and you use your system one, this is the problem, here's the solution. It won't work. But if you start thinking about it, like, okay, let's think about that step, and then this step, and then let's test it. Probably 100 steps, and you're done, right? Yeah, I got a yes. So same here. That's what's happening with the LLM. Okay. Well, I'm showing you here different. Like, I want to show something really cool. That once you implement a flow, an agent, sometimes the gap between mediocre models to very good models, actually the gap is being closed. But I don't want to get into too much details. I want to tell you that at Codium AI, we really believe in open source and sharing. You know, we're a developer tool. So we actually, not open source this solution, we actually provided all the tips and all the information, like a lot of the know-hows of how we came about for this solution. You can find these in our paper. Just look for like Codium AI, Alpha Codium, or Alpha Codium, or etc., and you'll find a lot of these tips. Let's zoom out, okay? I talked like in the beginning, like generally about I'm going to talk about the future of software development, and then I said, wait, but the code itself is not accurate. How can we like actually talk about the future? And then I said that the problem is that we're designing systems that are system one. We need to move to system two, which is more like an agent. We talked a little about an agent. I gave you an example of an agent that does much better, much better than other tools that is called Alpha Codium. And now let's zoom out and try from this to talk about a bit about how the future is going to look like. UX, UI, user experience, etc. Okay? So just a few hours ago, there was another lecture. You like it? Approve? Okay, cool. One of the leaders of GitHub Next, Ido, right? And he talked about like the past user interfaces and the future user interface. And one of the things I really liked, he also like moved from talking about system one to starting to talk about like system two. Like you see, there is a flow here. It's not like from query to code. It's actually from query to spec to plan. By the way, something is missing. The testing is missing, but okay. We presented in Alpha Codium how important it is. And I love this figure as well. Like, it's an iterative process, like we mentioned. And I also really love the idea is that the interfaces that we're going to see in the future is not only like the simple code completion or chat, which is complicated. It's going to be like, for example, editing of documents and then like the editing spec and getting the app, etc. I really love that. I mostly agree. But I have two things to add. One is simple. I already said the testing is a key factor in enabling this future like paradigm of let's work with specs, let's work with plan. It's a key factor, okay? And the second thing, it will take me 3 minutes to explain. So let's look at how, like generally speaking, it's called the V motion of software development, I think. What you see here on the x-axis is the development time. I usually start with a spec, and then I implement, and then I test it, and then I deploy, etc. Right? And the y-axis is how executable this text is. Spec is not executable. Implementation should be executable. If not, you're in trouble. And test is like almost executable, but not as part of the app. Right? This is Gen 1.0 like software development process. Somebody does not agree? Okay, cool. By the way, this is 2.0. Almost nothing changed. What changed is that now we have assistants. We have GitHub Copilot in the implementation, and we have Codium as the testing assistant. That's GitHub 1.0 and Codium, my company, 1.0. Now we're going to talk about 2.0. But this is basically like all the difference between Gen 1 software development to 2.0. By the way, nobody raised his hand, but some like orthodox, like some people like believe in TDD, right? It's like, hey, we should write. Notice that my x-axis of time like moved to within the arrows. So you start with specification, and then you want to do tests, and then you want to do the implementation. That's like another way to do it. Some try it. It's very good. Do you like it? No? It's like 5% of the developers, I think, right? Like we have one no. But I'll get back to it. Okay? So this is how we think Gen 3.0 is going to look like. Okay? Basically, we're talking about the dry concept. Developers know what I'm talking about. Don't repeat yourself. We repeat ourselves. We write our spec, we write tests, we write code. All of this is repetition, right? To some extent. Our original dry concept is not repeating the code part. This is also important. But we're repeating ourselves and test and spec. That's what we hated. AI is here to help us to do drive-by AI. I write my spec, the test and code changes. I write my code, my test and spec changes, etc. And AI agents that are capable to integrate in many places will help you to do that. So when you really want, you can try to do TDD. It will help you, but you don't have to. You'll be free to do any way you want, and you'll be drive by AI. Okay, that's what we're aiming at, by the way, in Codium AI. I didn't mention that there's also an error on the test, etc. That's like how the full vision of how it's going to look like. So to summarize, from the AI slot machine, you remember that the first, I think like one of the first slides, from the AI slot machine to an AI teammate. AI will meet you where you're going to work. If you're in your IDE, that's what you see here on the left part. It's like our IDE extension at Codium AI. And your Git, that's what you see on the right part. AI is going to meet you in your Git. It's going to meet you wherever you work to enable you to be drive by AI. It will integrate your entire software development lifecycle. It's very important. And it will empower you not only to code faster. There's so many use cases. It will empower you to code, test, and merge with confidence. And it's going to empower you. Even if it's another teammate, it's there for you. Yeah, that's it. Just I didn't say too much about Codium AI. Like I throw some of our vision, like some words about our extension, but I get so many questions about us, so I do want to say a few things. We have open source. We really believe in it. A research project which is 10 days old and already 2.3K stars. The project that I told you about. We have like a Git plugin which is really awesome. Better than GitHub's one, and it's so different, much more focused on testing, merging, etc. And it's also open sourced. And we have our IDs with hundreds of thousands installation. I'll love to have you try it out and tell us what you think in our Discord and GitHub or wherever you want. Our plugin is called PR Agent, our Git plugin PR Agent. Our ID extension is called CodiumAI. Thank you so much. Who counted how many times I said the word agent? How many? Cool.